Welcome to the next video. So now we're going to talk about negative and fractional indices. So this is just an extension of the first chapter where we discussed different rules of powers or indices. There's a few additional ones now we're going to cover. So I'm just going to write them out and we're going to go over them one by one. So the first one, the general form of it would be a to the power of 1 over m. Now we can write that like this, a to the root with a little m outside. So I mean, this is a little bit confusing when you first see it. So I mean, what does this practically mean? Well, if we had something like a to the half, so in other words m is 2 in this case, then that's simply a root with a little 2 according to this definition. Now we don't write a root with a little 2 actually in maths, we just write it as square root of a. So that's what that means. So if we had something like a to the quarter, in the same way that would be like this, we call this a to the 4th root. Now an extension of that first rule, we could write something like this: a to the power of n over m is the same as a to the n to the mth root. And there's actually another way we could write that. So that would also be a to the 1 over m to the power of n. So where am I getting this from? Well, if you remember from a previous video, we said x to the a to the power of b is equal to x to the ab. Now that is also the same as x to the ba. They mean the same thing. A times b is the same as b times a. So if we have a look at this a to the n over m, well, using that rule, x to the a to the power of b rule, we can write that as a to the n to the power of 1 over m, or we can write it as a to the 1 over m to the power of n. They mean the same thing. And then this is simply a to the n to the mth root. We can write it like that. And it's also the same as a to the 1 over m to the n. So these are both interchangeable. So practically, how can we apply this rule? Well, let's say we had a question like this. We had 9 to the power of 3 over 2. Something like that. So in this case, what we can do is say that that is the same as 9 to the half to the power of 3. We can say that. And 9 to the half is just 3. So this will be 3 to the power of 3. And then that is just 27. Just incidentally, if you didn't have a calculator and you wanted to work this question out, or any question similar to this, I would always do it in this way. In other words, I would always apply the denominator first and then the numerator second. So first and then second. The reason for that is if I show you the other way we could do this. So this is also the same as 9 to the power of 3 and then square rooting that. Now 9 to the 3, obviously that's already quite tricky to do without a calculator. So you will get the same answer, but obviously without a calculator it's much easier to do the square root of 9 and then cube that, rather than cubing the 9 and then square rooting that. So the cube of 9 would be 729, and then we still need to square root that, and then that would be 27. So obviously a much harder scenario if we did it this second way. So I would always recommend applying the denominator and then the numerator afterwards. Okay, so the last rule would be a to the power of minus m is equal to 1 over a to the m. So practically, how could we apply this? Well, let's say we wanted to work out x to the power of minus 3. That's the same as 1 over x cubed. So a more common version of this would be x to the minus 1 is 1 over x. So it's very important to understand this kind of thing, negative powers. So let's try and bring all this together then in a series of questions. So the first one would be to simplify this expression using any of the rules that we've covered in this session, or in fact the first session. So what we could do to start with is we could split this fraction up, and we've gone over this kind of method before in a previous lesson, so we're able to do this. So we can keep the denominators the same, 12x to the power of 7. And then what we want to do is try and cancel each of these fractions down. So firstly, we can just look at the 3 and the 12 and cancel those down. So that would be a quarter. So the 4 would be on the bottom and the 1 would be on the top. And then we've got x cubed over x to the 7. So we can use that rule from a previous session, which was x to the a over x to the b is equal to x to the a minus b. And so this would then mean that we've got an x to the 4 on the bottom. And then similarly over here, so it'd be minus. And then we want to cancel down 9 and 12. Well, 3 goes into both 9 and 12. So dividing top and bottom by 3, that would become 3 on the top and 4 on the bottom. And then the same kind of idea, x squared divided by x to the 7 is just going to be x to the 5. Okay, and then, well, maybe we would like to write these as negative powers. I mean, you could argue this is fully simplified at this point, but maybe we could rewrite it in another way, just for understanding. So what we could do is, if we look at the quarter x to the 4 on its own, now another way we could write that is a quarter multiplied by 1 over x to the 4. And 1 over x to the 4, by using a rule that we had earlier, that is going to be x to the minus 4. And then we still have that quarter outside, so we could write it that way. It doesn't necessarily matter which way you write it in unless they specify it in a question. And then if we just look at 3 over 4 x to the 5, in the same way, that's just going to be 3 quarters and then x to the minus 5. So you could simply bring them both together. So that would be a quarter x to the minus 4 minus 3 over 4 x to the minus 5. Okay, let's have a look at this question. So we want to simplify this one. Again, trying to bring in any relevant rules. So the first thing we could do here is rewrite this as x squared, and then instead of this bracket, we can actually write that as 3 to the power of 3 times x to the minus a quarter to the power of 3. So that is a rule that we came across in our first session, which is essentially saying that x, let's say xy to the power of n, that's the same as x to the n times y to the n. So you're allowed to do that. It's quite helpful to understand this process in some of these questions. So if we go a bit further then and simplify this, so 3 to the 3, so we had that earlier, that was 27 x squared, and then this one, that's going to become times x to the minus 3 over 4. Okay, so this one, where did that come from? X to the a all to the power of b is equal to x to the AB. That's where that one's coming from. Okay, and then we want to go a little bit further here. So let's try and simplify this. So we want to bring these two together. Now we have a rule that we came across earlier. X to the A times x to the B is equal to the sum of them, x to the A plus B. So we can use that here and essentially add the 2 and the minus 3 over 4. So that's going to be 27x to the 2 plus minus 3 over 4. That's going to become 27x to the, you could do it this way, 8 over 4. So that's the same as 2 minus 3 over 4. And then that's simply going to be 27x to the 5 over 4.